So now we're looking at the graph of y equals tan x, and again, just from 0 to 360. Remembering as well before we start with our all stations to central, that we expect tan to be positive in quadrant 1 and quadrant 3. Okay, so let's look. Can someone tan of 0, please? 0. Tan of 90. Error, undefined. So, tan of 90 is undefined. Undefined. Tan of 180. Okay, tan of 270. And tan of 360. Okay, so just having a look at the results and when they're graphed, this graph does not repeat every 360 degrees. It repeats every how many degrees? Yeah, every 180 degrees. So we know, so if you're looking here, we've got 0, 90, 180, 270, 360 over here, and then we've got the negative angles back here, negative 90, negative 180, negative 270, negative 360. So we're looking at quadrant 1, positive. All quadrant 2, it's negative. Quadrant 3, we're positive. Quadrant 4, tan is negative from 270 to 360. Okay, now tan is positive in quadrants 1 and 3, and it's negative in quadrants 2 and 4. So looking at where tan theta is 1, it's from your exact values, we know that tan of 45 degrees is 1. Also looking at the graph where tan theta is 1, it happens here, 45 degrees, and what do we think this one is? Halfway between 180 and 270 will be 225. So, and where is tan theta negative 1? If we look across here, it's in quadrant 2 and here in quadrant 4. Now it is halfway between 90 and 180, and it's halfway between 270 and 360. So, do you want to have a guess where those might be? 135. Yeah, 135 and 315. So where do these come from? So in quadrant 1, tan 45 is 1. Okay. In quadrant 2, okay, there's just a typo error there. Can you fix these up and make them tan 135? So tan of 135 is negative 1. 135 is a quadrant, falls in quadrant 2, so it's, remember we've got 180 minus theta. We're interested in the acute related angle. So this angle here that touches the x-axis, so it's 45. We know that tan is negative in quadrant 2, so it's negative tan 45. Quadrant 3, tan of, sorry girls, that looks like it's a mistake, of 225, right? Sorry, another typo, is 1. Quadrant 3, to get to 225, it's 90, 180, 270. So 90, 180, 180, the related acute angle in quadrant 3 is 45. So we know that 225 is 180 plus 45. We know that we've got all stations to central, that tan is positive in quadrant 3. So the tan of 225 gives us the same answer as tan 45. And in quadrant 4, 315, 90, 180, 270, 315, the related acute angle in quadrant 4 is 45. So we know from our graph tan of 315 degrees is negative 1. Quadrant 4, it's always 360 minus that acute angles. That comes from 360 minus 45. So the tan of 315 is the same as positive or negative tan 45. All stations to central. Tan is negative in quadrant 4. Okay? So, and we'll do a whole lot of those on the next page. So note that the function is undefined for values of what? Go. 90, 270. If I want to do the negative ones, what are the negative ones as well? Negative 90 and negative 270, etc. etc. The graph of tan theta repeats every 180 degrees. So we say that the graph has a period of 180 degrees. And what sort of symmetry does it have? Line or point symmetry? It has point symmetry about the origin. So it's symmetrical about the origin. It is not symmetrical about the y-axis like the cosine curve. Just looking at those values again, and if you're ever not sure whether tan 0 is 0 or tan 90 is undefined, you just use your calculator. Okay, so knowing again that it repeats every 180 degrees, and we have asymptotes. So, sorry, I meant to go back and talk about that. So notice it's undefined for 90 degrees to 70. We have asymptotes. So I'd be putting little arrows on these graphs. So 90 degrees is an asymptote. You can never have tan 90. You can do tan 89, tan 89.9, tan 90.1 will all work, but tan 90 will not. It's undefined. Same with tan 270. So you've got asymptotes there. Okay? And the graph approaches the asymptotes but never touches. Okay? All right. Now, all right. So, all stations to central, we know that for all the ratios, sine, cos, and tan, anything between 0 and 90 degrees, you have positive, they are all positive. Only sine is positive in quadrant 2, only tan is positive in quadrant 3, and only cos is positive in quadrant 4. So if we're looking at tan 100, then it is going to be negative. So if we look at 100, we're not interested in the 100, we're interested in the related acute angle in quadrant 2. This sits in quadrant 2. So what's this angle in here? 80. It's 80. So it's the same as negative tan 80. If you can do tan 140 as well, what have we got? The acute related acute angle is 40, but you'll have negative tan 40. You can do those in a minute. Let's look at quadrant 3, tan of 190. We go 90, 180, and how many more degrees to get 190? And 10 more. Is tan positive in quadrant 3? All stations 2, so it's positive tan. Tan of 230, how many more degrees? 90, 180, with another 50 degrees just there. So tan 50, again, it's positive. And you can do the others. And in quadrant 4, tan of 280, 90, 180, 270, plus how much more is 10. But I'm not interested in that little bit more there. I need the angle that touches the x-axis. What have I got? If that's 10 there, what have I got there? 80. So we're sitting in quadrant 4, so tan is negative. The related acute angle is 80 degrees. So it's tan 80, but because in quadrant 4, tan is negative, it's negative tan 80. And tan of 330, 90, 180, 270. If I go 330 all the way round, what's left over here? So, but negative tan 30. So I'll just give you a minute to fill the rest of those in. Answers, good idea to draw them as well. Okay, just drawing a couple, tan of 120, 60 left over in there. Tan of 220, 90, 180, and 40 more. Okay, so remembering with all of these, it is, you know, our little butterfly. It is, if you're in quadrant 1, I want the angle touching the x-axis. Quadrant 2, the angle touching the x-axis. Quadrant 3, I need, if you're coming all the way around here, angle touching the x-axis, and same in quadrant 4. Not interested in the other angles in there. Okay? So whenever you're looking at an angle greater than 90 degrees, you have to write it as an acute angle with a positive or negative in front of it. Okay?